Hello and welcome back. So far we have understood all the necessary techniques to build a classification model and make the model the best by playing with the thresholds and getting the precisions and recalls, the numbers we wanted. And we understood how exactly the gradient descent algorithm is working to find out thetas on a logistic regression also. So a logistic regression algorithm can be used to do a non-linear decision boundary also. If the data is like this, all ones are around and all zeros are inside, you need to do a non-linear decision boundary, a circle. If the equation is a non-linear equation, the boundary is going to be non-linear decision boundary and the model works. So logistic regression algorithm can also be used in non-linear setup. So that's what the point I wanted to make. But if the number of columns are too many, and if you create the polynomial degree, the higher degree polynomial, right, the model may not work because of memory issues and processing issues. There, the deep learning comes in to save us. So that is one point I wanted to make before we end this binary classification section. And then there are other metrics, simple metrics to understand whether model is working or not, graphical tools. So precision recall curve is one tool. We know that by using precision recall curve method here, we can get different precisions and different recalls at different thresholds. We can use this precision and recalls, these scores, the precision score and recall score, and draw a graph like this, which actually focuses more on the positive class. Or when your data set has got less number of records on the positive class, you should be drawing the precision recall score, the precision recall curve. And if the curve has got more area under the curve, then the model is working good. Or in other ways, if you have less space here, the model is working good. If you have more space here, there is room for improvement. How do you improve model performance? By making the model more complex or playing with the hyperparameters. So the area under the curve is high, the model works good. That indicates that model is working good. Precision recall curve is drawn for different precisions and different recalls at different thresholds. Okay, and then the ROC curve. ROC curve works like accuracy score. For the same data set, if you look at this, here it shows that there is room for improvement. When the data set is imbalanced, precision recall curve is actually showing you that there is room for improvement. This is good. But when you look at ROC curve, it is not showing, it is showing less space here and more area under the curve. So it works like accuracy score. It actually does a graph between false positive rate and true positive rate. To draw any graph, any line like this, you need different data points. How are you getting different data points here? At different thresholds, we are calculating different false positive rates and different true positive rates, because at different thresholds you will get different confusion matrix. We have seen that. So using those confusion matrix, we are actually calculating different false positive rates and false true positive rates and drawing these graphs. And by looking, you can actually use ROC AUC score method to calculate the area under the curve. We have got 97% accuracy. This is not right because the data set is imbalanced, and we know that the precision score and recall score at 0 are 93 and 78. That means if you calculate F1 score, right, it's going to be kind of 84%. So in this particular case, you need to use precision recall curve. When the data set is balanced, you can go with ROC AUC score or ROC curve. So that ends the classification, binary class classification, logistic regression, and how to play with thresholds and get the precision and recall scores you desired. Thank you.